next speaker is Steffen, and he's bringing a lot of stuff.
Yeah.
Right. So Steffen writes. He's a software specialist and open source enthusiast from the region, from Aachen, and he's working in real-time simulations of electrical power systems. But when he's not working, he likes to hack on retro hardware and mesh networks and reproducible package managers. And the title of his talk is Managing Tape Archives with git-annex, a special mode for sequential media.
Thank you. Okay, perfect. Thank you a lot. It's quite nice to directly speak after Joey because he helped me to basically get this done. I want to talk about a special remote using magnetic tape. You see it on the picture here. That's one of the first iterations of that. It's an IBM system, but nowadays it's still in use. It's a quite interesting technology. And I use it for my personal data, and I want to show you how it's done. Sequential media is kind of the broad term about it. There are other types of sequential media. Sometimes it's also, it's the first type of computing storage which was there really, was introduced in the 50s with an IBM 7 and 9 track system, and 7 and 9, let's keep that in mind because we will see how that evolved over time. It's also sometimes called sequential access memory. So if you know RAM and ROM, it's kind of the same acronym here in the same family. It's used as secondary, long-term and cold storage. So really not something you use day to day, but something where you can store a lot of data for disaster recovery, archival, and backups. And that's what I also use it personally for. It's quite popular in corporate environment. You won't find it on your consumer environment. Maybe you know S3 Glacier, that cold store from Amazon. I don't know exactly, but I'm assuming that they also use cloud storage in the tape storage in the back. It's still popular with video production environments because they're dealing with a lot of data, and storing that on hard drives is sometimes not feasible for them. And that's where I'm coming in. I see a lot of people using that in their home labs or as data hoarders, because with the history of that technology, there exists a lot, and it's still developed. So a lot of these devices show up on eBay and where else, and you can get them nowadays for relatively cheap and play around with them. Tape also has a quite high durability or life expectancy. It's said to be durable for up to 30 years. Which, to my knowledge, not a lot of other media can achieve. Has low power consumption because if you put it on the shelf, you don't have a platter spinning. And it's shippable. I have a tape here with me. It's small, it's lightweight, it doesn't break immediately if I drop it like a hard disk. So I can just put this into a box and ship it to my colleagues. And yeah, affordability, the media is cheap. But we will come to that the drives are actually fairly expensive. And on the second-hand market, you can get these tapes for 10 to 15 euros per terabyte. What are the challenges? Yeah, as I said, drives are really expensive. Like the old ones, you can get used, start around 500, 600 euros. But if you want to get a up-to-date, like latest generation device, you're looking for more like 3,000 to 4,000 euros. Tapes are slow. It's not a random access device, so you cannot just access any part of the media. You have to spool it, seek it, and that can take time. All that mechanical motion introduces wear, so the media have limited lifetime. If you use them too much, that's why you usually want to only use them for cold storage. And yeah, as a enterprise technology, connectivity options for the drives are fairly limited, so mainly only SAS and Fibre Channel. And you have to be a bit careful if you store the media, because It's usually put in a tape archive, and you have a data center. It's nice and cool, so that's where it's made for. Should be careful not to have it exposed to light, to be in a too warm or too humid environment, because then the life expectancy will degrade. So you're not gonna get these 30 years. Here I have a quick plot about how the technology evolved, and we see a few in different colors, a few different tape technologies. Starting here in 1998, but that's only because there were a lot more before, actually, but those are the ones which stayed. And we see that right now there are mainly still two platforms available, one proprietary from IBM, and then LTO, which I'm going to talk about mainly. It's interesting to see that IBM is still pushing that technology quite far, and nowadays we can get up to 50 terabytes on a single tape in that size. And also demand is still there. The industry group who is developing LTO as a technology is publishing yearly figures, how much tape cartridges they are shipping. And it's still growing, which I find quite interesting. At the same time, we see that hard drive shipments are actually a bit decreasing. That's due to the rise of flash. But I would say from that, we can derive that tape is not dead. We are still need to store massive amounts of data, and I think AI, and we heard it before, will not change this. We need to find a way of how we can train and store our training data sets and so on. So LTO is an open standard. I put open in quotes here because I was not able to find it. It's like still a... And it has it in the name, so it's a bit strange. It was invented in 2000 or in the 2000s by IBM, HP, and Seagate back then. Then ownership of Seagate changed a bit, or the tape division of Seagate. So nowadays it's Quantum who is building and selling devices. And they are sold under the Altrium brand. There was also some other companies, actually a German company called Tandberg building drives, but they ceased operations this year, which is a bit unfortunate. There are different types of drives available. We have internal drives, full height and half height. So in the middle here, we see a full height drive, and that's maybe for the newer generation, that was the usual size of a hard disk, of the earliest hard disk in that form factor. Only later on, it was then reduced in its dimensions. So we have the half-size drive. And I have like my little NAS here, has a 5.5-inch bay in here where I put one of those drives, which I find quite neat. And there are external drives, but they're a bit hard to deal with because they have the SAS and Fibre Channel interface. You won't find those on the laptop. I was hoping that I can do a live demo, and I actually could, connecting this via network, but it would be even nicer if I just have a USB connection, but it's not really feasible nowadays. Cartridges, yeah, they have a tape which is half an inch in width, so that's the height here basically. The tape can be quite long, so the latest generation has 1 kilometer of magnetic tape in that single cartridge here. And it's a single spool, which is different from, the audio cassettes, So just like we see it on the picture here as well, just a single spool. And there's a barcode on top, which is used by libraries or robots picking the tapes, and also some RFID memory inside it. LTO generations are still developed, and there's a roadmap from this consortium, which is publishing that they want to go up to half a petabyte in a single cartridge for the latest generation. That will still take a few years, hopefully, to develop. But still nowadays, we can see that we can reach up to 30 terabytes in a single cartridge with generation 10. And also interesting to look at the data transfer speeds here, where we are nowadays at 400 megabytes per second. So it's actually fast also. And if you have a large data set, you're not only having a single drive, you have multiple drives, so you can scale up the throughput as well. My drive I have here is generation 6, so that's 160 megabytes, and that's already too much for a gigabit Ethernet connection. So I'm struggling a little bit to get my data to my NAS if I want to really directly write it to a tape. There are quite a couple of different features coming with LTO. There's hardware compression built in from the first generation. Generation 3 introduced write-only read media. It's for compliancy reasons usually interesting if you can basically guarantee that stuff never gets deleted from a tape. There's built-in hardware encryption, which I'm also using. Partitioning, which we will see a bit. And then in the later generations, some more interesting features like media optimization, where basically the tape drive needs to spool through the media, optimize the media for that particular drive. And they needed to do that because the dimensions on the tape get smaller, and they had to optimize the media. And another feature called recommended access order, where basically the tape drive tells the application in which order it should fetch data from it. And that's something quite important also for the implementation of my special remote, which I come to later. So how does data on a tape is logically placed? Tape, as I said, it's a sequential media, so we have a beginning, the BOT, the beginning of tape, then we have a few partitions, they're separated by guards, and an end of tape in the end. Each partition, again, has this marker called BOP, it's the beginning of partition, then a couple of files which are separated by file marks, FM here, and then in the end we have something called an early warning, EW, or the PEW set, the programmable early warning zones, which are mechanisms for the tape drive to signal that you're coming to the end of the partition and you need to slow down or stop sending it, writing data to it. And then in the end we have the EOP, the end of partition. Each file then is just a series of blocks, and for various reasons to efficiently write and read data from tape media, these blocks need to be fairly large. So we are talking about a block about 256K or 512K sometimes, because otherwise we would have too much overhead in synchronizing with the tape drive and we are streaming data to it. If you look at the physical layout, so that was more like the logical layout, how an application would interact with the tape drive. The physical layout is even more complex. I won't go into detail here. There are servo bands to like figure out the position where the tape is currently, and then we have a lot of these channels. So it's not only like a single stream of data where the tape head goes through, but it's actually a lot of parallel channels and tracks. And if you want to read such a tape drive from start to end, you're basically passing multiple times over the tape. And for latest generation, you have to pass 472 times over the tape. The latest generation has 1 kilometer, so in length of total. So if you want to read the whole tape, you're basically spooling the tape for 472 kilometers to get to read it. Okay, so now about my special remote. I'm quite glad that I can skip a few slides here because I don't need to introduce git-annex anymore. We know basically from git-annex perspective, a special remote is basically something like a key value store. We are storing a key, we're getting the object. There are quite a lot of them, and what I do is basically I implement a new special remote. More precisely, I'm implementing an external special remote, so that's not part of the git-annex code base, but instead it's a sub-process or an external application. They are communicating with git-annex over standard I/O and a line-based protocol, which is fairly easy to understand. So I was basically able to implement my git-annex-remote-tape here, which then talks to my tape drive. Yeah, it's implemented in Rust. It's my first Rust project, so it was more like a hobby to get to know the language. And when I submitted a talk, I haven't actually started to write it. So I was a little bit under pressure for the last days to get it done. It's licensed under HGPL. And when I started, I thought I can just use the Linux driver for tape drives. So there's like under dev, you get for each tape drive, you get a device, and you can just use read-write syscalls for it, and some I/O CTLs to do all the seeking and positioning. And then later on, a note, I noticed it's maybe not that easy. And then I looked at how Proxmox is doing it. Proxmox, a virtualization tool, has a backup server. That backup server is implemented in Rust as well. And they already implemented a user-space SCSI driver for tape drives. So I took that, heavily refactored and changed it. And nowadays, I'm basically in my remote, I'm sending raw SCSI commands to the tape drive. That's based on SG3utils, which is a C library to communicate or to send these raw SCSI commands. It has a nice advantage that this is portable, runs on FreeBSD, Solaris, and even Windows. And I do all my testing in NixOS. And it's quite nice because there's MHVTL, which is a virtual tape library. So I can basically emulate tape drives and libraries in software, and that allows me to run my whole test suite in the VM using a virtual tape drive. Code is available here on Codeberg. So now how to use it. I was planning to do a little demo, but time is running fast, so I'm just going to show you the command. I have like a dedicated CLI tool, which allows me to manage the cartridges. So here I'm formatting the cartridge, and then I use the usual git-annex command to initialize a new remote. And then I can use git copy, get, and then here, little speciality, because we will see that in a second why I have to run a second command to actually fetch the data from the tape drive. My special remote is managing each physical tape cartridge as a dedicated remote. So you can end up with like 100 git-annex remotes because each tape drive, each cartridge is its own. Yeah, my special remote supports the hardware encryption and compression features of LTO, so I'm not using GNU PGP here. It's possible thanks to a feature Joey developed, where we can use git-annex encryption features, but only to encrypt credentials and not the data itself. So I'm encrypting a symmetric key, which I'm then sending to the tape drive to do all the encryption for me. There's this two-step process for retrieval, and that's something I hope maybe to be able to eliminate in the future. And it's append-only, like usually you're only writing to the end of a tape, so there's not really a way to drop data from the cartridge. Otherwise, or I need to reformat and I basically forget about the whole remote. I'm going to skip a bit about over the format. You can have a look at it in the slides later on. What I wanted to iterate a bit upon is this two-step process for getting data from a remote. The tape basically is sequential media, so I don't have random access. I cannot get to any point in the file. I could seek around, but that would feel really slow. So ideally, I want to fetch all my objects from a tape in a sequential order. And that's something on git-annex, unfortunately, right now is not really doable. As far as I know, it's just in this external special remote protocol requests objects in I don't know which order. So what I need to do is I fetch data from the tape drive, and on the first pass, I make it fail. And I only do that to basically get a list of objects I actually want to have. And I record this list of objects. Then I can order them to the actual positions on the tape, and I rerun it, basically using a quite interesting command line option of git-annex-get called batch keys. So I pass it all the keys that should retrieve in the order I have control over. I'm going to skip about that. I'm using a binary format on the tape based on CBOR. And the interesting part here is if we look, every operation on the tape drive using my special remote is writing a new file. So I have multiple files. That is nice because I can mix data from different git-annex repositories on the same cartridge because they are showing up as different archives. And I can also put completely different other data on the tape drive, not managed by git-annex at all. So I have to skip over that a bit. So what is the roadmap for this special remote? I want to support tape libraries. I have actually now one at home. It's like a 4U rack mountable device. So I can manage these tape cartridges automatically, and I want to have this remote automatically moving the robot and putting it automatically. I want to support iSCSI. Then ideally, I want to remove that need for this two-pass operation. I want to make it fully asynchronous using Tokyo. And I was thinking about a daemon where I actually want to use the new cluster feature, because I think that's a quite nice example. If you think about such a NAS here, it's like a little device. It has hard drives in it, so I have data stored on there. I need it as a buffer. But then I also have all these tape cartridges which I can put in. And ideally, I want to make that completely transparent to the user. But due to that two-pass nature of getting data, I think the current cluster implementation will not work because it will fail. So maybe we can see about that if we can fix this. Yeah, and then maybe as a last possible request to Joey here, or idea I have, I know git-annex is quite well in managing or location tracking of objects, but can we do that also for remotes? Like if I have 100 remotes and these are physical tape cartridges, I want to know where is it. I want to attach maybe metadata to it because I forgot where I put it. Is it at my parents' place as offsite backup? So this metadata management, not about object, but about remotes or location tracking of remotes would be something I would find really nice. Well, that's it. Thanks a lot.